A longtime resident and businessman in the area, Mr. Kent Taylor was born in Evanston, graduated from New Trier and Michigan State University. An entrepreneur by nature, he built and managed several consulting businesses. Now retired, he is pursuing his passion, saving the environment. Besides his profession, Kent had been for over 20 years a volunteer diver and presenter at the Shed Aquarium in Chicago. He lectured on coral reef ecology from inside their 90,000-gallon coral reef exhibit on the weekends. Maybe some of you have seen his underwater presentation. Upon retirement from the Shed, he was named Volunteer Emeritus. In 2007, he was among the first to apply and be selected to join Al Gore and his staff in Nashville. There, he was trained and authorized in the showing of Mr. Gore's famous slide presentations, first seen in the movie An Inconvenient Truth. He was one of the first members of the Climate Reality Project, an organization with over 15,000 members currently. Kent has given over 130 presentations and has received additional training from Mr. Gore on numerous occasions. As one of the Climate Reality Project's most active presenters, Kent is now mentoring other presenters at Mr. Gore's behest. What you will see today are the most current slides from Mr. Gore and his organization. Kent will speak for about an hour, and then we're going to open up to questions and comments. He hopes to leave you encouraged to work within our communities and exert significant political pressure to lower our collective carbon footprint and seriously address our climate crisis with action before it's too late for future generations. Welcome to the Garden Club of Lake Zurich, Kent, and I give you the floor, so to speak.
Thank you very much, Ann. I do appreciate the kind words. Spoken just like I wrote them. I always appreciate that. But, we're here to thank you very much to your club for inviting me to give this virtual presentation. I'd like to extend my appreciations to Mr. Al Gore, the inspiration of the Climate Reality Project and many of my activities as well. And of course, the Climate Reality Project, which is his organization and continues to support the efforts of thousands of people like me all over the world. I like to start my presentation with one of my very favorite photographs, and this is something that impacted me greatly when it was published, called Earthrise. It was a picture taken from the spaceship Apollo 8 after it circled the moon. It took this shot appeared. It was unscheduled. They just took it. Once it was published, it had a major impact on I think society. Many people like myself found it indicated how small we were as a planet, how isolated we were, the finite nature of us, and really how we have to cooperate to save this incredibly blue marble, which is the name of the last picture taken from Apollo 17, the last flight. This was a rehearsed, scheduled picture with the sun right behind the spacecraft. Incredible shot. Both these pictures really launched, many feel, the environmental movement. And by 1972, it was off and running, I say. But right now, as we face probably the most significant challenge in human history, there really is only three questions to ask and answer about our topic today. And that is, must we change, can we change, and will we change? I'm going to try to answer each of these questions tonight, and starting with must we change? Now, please be aware that there'll be some disturbing images ahead in this section, but images of things that were all predicted decades ago by scientists to occur, only it's worse. Now, don't lose heart. We have the last two sections are quite uplifting. as we show the path forward that we are already taking and will be taking. But our problem really resides with the fact that we have this incredibly thin atmosphere. It's only 6 miles deep, the troposphere part of it, the part where we have all our breathable air and all of our pollution collects. It is this part that we are performing a gigantic chemistry experiment on, which I'll talk about just in a minute. Because as you all know, solar radiation passes through this atmosphere and warms our planet. Most of this radiation is absorbed by the Earth, but a significant amount is irradiated back into space. But the natural occurring greenhouse gases in the troposphere acts to retain a significant amount of heat, enough to raise our temperature about 80 degrees globally. So or actually about 60 degrees globally. So it's instead of being 0 degrees Fahrenheit on average, it's about 60 degrees, a very important amount of heat. But now we're spewing hundreds of millions of tons of global warming pollution, greenhouse gases, into this thin shell every 24 hours as if it were an open sewer. This is the chemistry experiment we're conducting. It is essentially adding greenhouse gases and retaining an important additional amount of heat that is throwing off our natural world. And this is what is called anthropogenic global warming. Now, where do these greenhouse gases come from? Virtually all areas of our society, from our industries to our homes, even when forests burn, tundra thaws, it's all entering the atmosphere, but predominant, overwhelming amount is coming from the burning of fossil fuels, which provides today, unfortunately, 80% of the world's energy. But I think it's important to also get a very long historical perspective here, because the climate has been around forever. So by using ice core samples taken in the Antarctic, we can actually go back in time significantly, almost 1 million years. And by taking core samples and releasing the atmosphere frozen in time, we're actually able to measure the amount of CO2 and also extrapolate very accurately the temperatures that were associated with each epoch. And as you can see, the temperatures and CO2 go together like a lock and key. One goes up, the other goes up, and then vice versa. They are tied together like bread and crust, if you will. Now also note that every time the CO2 level dropped a little bit below average down here, with temperature plunging following, what happened is we got ice ages. It just shows you a slight change in these parts per million measurements can mean a climate can react very almost catastrophically to these very, very slight changes. So in Chicago, for instance, in the Ice Age, there was a mile of ice over our heads right here. So that's pretty catastrophic. But keep in note here that the average CO2 in parts per million over this time was about 230 parts per million. Now, let's look where we are today. Hold on to your hats. There we are. 415 parts per million, nearly twice the average of the last million years or so. Scientists have been also struggling to find out where we're headed, talking with economists, able to figure out our consumption patterns, that if we don't change the way we consume energy, this is where we'll be in 40 years, at over 800 parts per million. Now keep in mind, if a change to the downside of going from a sunny day in Chicago down to an ice age this way, what will happen when it goes this way? It won't be good. And right now, CO2 is being released in the atmosphere faster than any time in at least the last 66 million years since the death of the dinosaurs. This from proxy data of beyond just ice core samples. So we are already seeing this being reflected in our temperatures. It's already starting. 19 of the 20th hottest years on record have all occurred since 2001. 5 hottest years have been the last 5 years. But look at it this way. The line in the middle is the 20th century average. You can see that since 1980, all we've been doing is going up. And there's enough data in already that says that a better than even chance that 2020 will be our new hottest year ever. Seeing a trend here? Well, I'm going to talk, the observational evidence I'm going to use today is really only over the last 2 years. And believe me, there is enough just over that period of time. But during the last 2 years, 224 locations around the world set all-time heat records. And one that stood out to me in particular was set in Oman in 2018, where it was 108 degrees overnight, which the sun wasn't shining then. That means the greenhouse effect was in overdrive. And the town remained at above 105 for another several days. In 2019, Europe had their hottest year on record. Many countries set their all-time temperature records. We can just look at one, for instance, and this was Paris, France, that hit their all-time record of 115 degrees, beating their old record by full 3 degrees. Australia hit 121 degrees, and that's southern Australia, the furthest away from the equator. In Japan, where they're just not used to hot temperatures and there's not a lot of air conditioning, 600 people were hospitalized in 2009 due to high temperatures. And just this past year, Miami recorded its hottest week ever, and believe me, they've had quite a few hot weeks that this had to beat. And in much of Africa this year, all-time records were set as well. Early in the year, the Australian heat wave returned with ferocity. But let's, I like to say any talk about climate really has to include the Arctic. The Arctic is a floating ice mass that I'm going to talk about here. It's all floating. And then this is Greenland on the side. This is land-based ice. I'll talk about that in a minute. But notice the Arctic is surrounded by land, even though it's floating. And it is, the temperatures are increasing faster there than any other spot in the entire world. Why is this? Why is it increasing so high? Well, for the eons, the radiant energy is reflected off the white surface of the Arctic and the white surrounding land back into space harmlessly. But as the warmer waters encroach, as the Arctic shrinks and as the ice recedes from the land, it all turns dark. And the sun's light is then retained, and we're literally creating a heat sink in the Arctic. Now, all natural systems like the planet Earth have a means of equalizing its temperature over the entire system. And our climate does that for us here. The air that accumulates and water that accumulates near the equator is much hotter than everywhere else. And the climate acts as a heat exchanger through an ancient series of underwater currents and air patterns that bring this heat both north and south to the poles for cooling. And this stabilizes the system. But as we know, the temperatures are increasing. And if we were to go up 1 degree centigrade around the equator, unfortunately, due to the reasons I already described, the Arctic would go up 3 times as much. And what would this do? It would totally throw these ancient patterns into disarray. They'll exist, but we don't know where. Civilization was built on the predictability of these currents and wind patterns, and things will have to change because these are changing. But well, haven't we already seen a 1 degree Celsius increase since the pre-industrial age? Yes, we have. And we have seen these wind patterns changing. This is the normal stable polar vortex. This is what's been happening more recently. It gets wavy, and the warm air proceeds north and the cold air south. And this has been happening more and more frequently. This is what used to be the normal winter jet stream several decades ago. This is what we have now as our new normal. And this is what is pretty normal right now, looking down on the Earth from the North Pole. But some strange things have been happening of late. In 2018, this polar vortex was literally split in two by a stratospheric warming event. It split the vortex into to North America and Eurasia, bringing bitter cold south and very warm temperatures north. This is what it looked like when that happened. And you can see the warm air coursing up to the poles here, as you'd expect. The poles suffered that at that time. Matter of fact, they were 50 degrees hotter than normal in the middle of winter. So ice was melting at the North Pole in the middle of winter in 2018. And conversely, it was snowing in Rome. Yes, our weather is getting crazy. But this is not just 1 year of anomaly. These heat waves up in the Arctic have become regular events 3 years in a row. In 2019, we didn't bring as much heat north, but something really weird happened too. It split, the vortex split into threes. And this brought tremendous cold down south to both Siberia and North America. Look at that date, and this is what Chicago looked like on that date. Our weather has been quite volatile lately, and nothing raised alarm bells more than an unpronounceable town in Siberia reaching a temperature over 100 degrees above the Arctic, 100 degrees, and this is above the Arctic Circle, the first 100-degree temperature ever recorded there above the Arctic Circle. As you can imagine, the ice has been collapsing all throughout the Arctic. Now let's look at Greenland. Greenland, the ice is on the land, so when it melts, it increases our sea levels. The white area represents the 40% of Greenland that isn't melting. The 60% has been under a barrage of melting forces. One day last year, it lost 10 billion tons of ice in a single day from the 60% that is melting. Glaciers near the coast used to look like this 70, 80 years ago. Now that same glacier looks like this, mostly water. The ice levels have been plunging also in Greenland. And when this water leaves the ice, it goes right into our oceans. Now let's look at the other part of the globe. This is Antarctica. Now, Antarctica has been thought to be immune from a lot of these forces until recently because of its location being very obviously at the South Pole, but also its altitude, which is much of it's 10,000 feet high, especially this eastern 2/3. But unfortunately, we've had instrumentation has now been dispersed enough that we're starting to realize now that this area that contains 90% of all the ice in the world and 70% of all the fresh water in the world has also been melting, especially this western portion that is very low altitude-wise, some of it even below sea level. There's enough ice here that if it all melted, it would raise worldwide sea levels by 20 feet. We're already seeing high tides higher than historical averages. Many infrastructures of cities on the coast have been built for the old high tides, and now these new high tides are overwhelming the infrastructure. Now, what does this have to do with an octopus walking around a parking lot in Miami? Well, that's because Miami is an unusual situation. See this sewer back here? This octopus came out of that sewer. And what's going on in Miami is built on old coral reefs. So it's limestone. And limestone is porous, so it doesn't matter how high you build the breaker, the walls, the sea walls will never hold back the ocean because it's going underneath and coming up through the rock infrastructure. And that's where this little guy popped out of, and he's looking for Nemo there somewhere in this parking lot. But that's why Miami is, in terms of assets at risk, #1 in the world. Notice New York #3. All of the other cities at risk for ocean level rise are in the Asian subcontinent. Now, one reason we haven't felt as much as the scientists thought we would feel in terms of our land temperatures is that, for some reasons that still haven't been explained to us, 93% of the extra heat generated by our activities has been absorbed by the ocean. With all due respects to Las Vegas, what goes on in the ocean doesn't necessarily stay in the ocean. And what you can see here from a similar graph, about 20 years later, after the atmosphere started rising, our ocean temperature started rising in the same ominous pattern. And 2020 is, again, likely to set a new record for ocean warmth. And this is not just surface warmth. This temperature increase is penetrating 2,000 meters and more into the ocean, which is changing not just the temperature, but the biology and the very chemistry of our oceans. And half of this increase has all occurred just in the last 20 years. So this is accelerating very, very rapidly. And like I said, what goes in the ocean doesn't stay. And where this ocean heat expresses itself most frequently, is in hurricanes and tropical and storms and circulatory storms. Remember Hurricane Harvey? It increased rapidly just before it hit shore to nearly a Category 4, and it just hung around there for days because, one, when it went out to sea, it got 7 degrees hotter warmth to keep it going, and it kept bumping into one of these wavy jet streams. In Nederland, Texas, they had 64 inches of rain from this storm. It was an unmitigated 1,000-year rainstorm disaster. But this is a trend of a lot of our hurricanes lately. Hurricane Florence also lingered and just sat there. It was only a Category 1, but it put 30, 40 inches of rain in the Carolinas. You remember last year's Hurricane Dorian, most powerful storm ever recorded in the Atlantic Ocean. When it hit the Bahamas, it stuck there. Did $10 billion damage. It stalled for 40 hours over this poor Abaco Island, jumping 60 inches of rain. These are different. These are anomalies that weren't common. And look at this, Hurricane Sally. Remember, it did the same thing. It was creeping along at 1 mile an hour, taking forever to get to land, and did the same thing after it hit land. But this picture also, look at 5 other circulatory storms in one image, the first time in the satellite era that has been captured. Frightening, isn't it? This was the storm tracks of all the storms in 2020, the most active season in the history of the North Atlantic. They had 30 named storms, 12 made landfall in the U.S., 13 hurricanes, 6 major, the 50th consecutive above average season. They ran out of letters in the alphabet for only the 2nd time to name these storms. The last one was named Iota. What's going on? We are energizing our hydrological cycle. Right now, there's 4% more water vapor in our atmosphere over our oceans because the atmosphere is hotter. That if what goes up must come down. So that leads to increased precipitation, both in terms of rainfall and snowfall and sleet and hail. And all this water eventually makes its way into the streams and rivers and ultimately returns to the ocean. This cycle is being energized by the heat in our atmosphere. And also, with the increased carbon in the atmosphere, A lot of the storms are becoming very localized. Now, this is kind of a graphic picture of such an effect, but meteorologists are calling them rain bombs because they tend to hit smaller areas and the rain is just so intense it doesn't do any good. It just does damage. But the farmland of our country has been suffering greatly under these new circumstances. This is Pacific Junction, Iowa in 2018. This is what it was about 6-7 months later after in the spring floods. People isolated in the town, crops being unable to be planted. The governor there, not willing to admit to a problem, refused to declare a state of emergency until weeks later when it was as things were receding. In Nebraska at the same time, this governor had no trouble calling a state of emergency. Matter of fact, he called it through 2/3 of their counties. And they got a good portion of the $6.5 billion in federal crop insurance, another $20 billion in damages that were done in spring flooding throughout the central United States last year. This climate change thing is getting expensive. And now we're seeing, again, these bar graphs are really indicative of what the change. You see that these precipitation anomalies increasing rapidly just over the last decade or so globally. So all over the world, this is happening. At least 44 people were killed in this town in Japan after torrential rain flooding in mudslides. Nearly $3 billion in damage, and 63 people lost their lives in this Chinese province earlier this year. And in Guadalajara, Mexico, in the middle of summer, they were hit with 5 feet of hail overnight. This is crazy. Don't think the insurance companies have not noticed. This has been Munich Re, the largest reinsurer in the world, that documents this every year. The amount of claims that are going out for extreme weather events and what type of events are causing these claims. Notice your insurance rates going up. This is part and parcel as to why. And then an amazing bit of irony, this rain has even affected the Noah's Ark replica in Williamstown, Kentucky, which apparently the insurance company was surprised to find out really was not immune to rain. And they had to sue, and they recovered $1 million in damages for rain damage to the Ark. Those that like irony, loving that. But this is just added to the bill for the last 2 years worldwide of over $650 billion of economic losses due to extreme weather events. Now, here's an interesting topic, hard to get your brain around. The same extra heat that drives precipitation and causes more downpours and floods also extracts moisture more quickly from drought-prone areas and exacerbates causing the drought, causing them to be deeper and longer. And we're seeing droughts all over the world. Some of the largest cities in the world. In Chennai, the 6th largest city, their aquifer is nearly dry. Think about having to plan your day by first going to the nearest pump somewhere or stream to collect water for the day. The same thing happens in Cape Town, South Africa. Cape Town is one of the most vital cosmopolitan areas in Africa. And in 2018, they were days away from having to turn off their water spigots. Iran has been in severe drought since 2018. Parts of Australia have been in drought for the last several years. In 2018, it was the worst drought in their living memory. And what happens with the drought, of course, follows up with the dry tinder of the forests, the grasslands, the wildfires. And we remember these wildfires from earlier it seems like an age ago before COVID, but there's incredible fires in Australia destroying thousands of structures. The fire consumed an area the size of Kentucky, leaving more than 20 people dead and thousands homeless. And of course, we all remember the heart-rending pictures of the animals, the innocent victims here, trying desperately to survive, but experts have told us that probably over 1 billion animals were killed in these wildfires in Australia, and many of the rare species now do not have enough viable mates and may go extinct. What put out the fires? Another major climate catastrophe. 8 inches of rain in 24 hours, the heaviest rain in 30 years. So it took another climate event to put out the results of a previous climate event. The world is getting very complicated here. Here in the United States, we're noticing that also as temperatures increase, the fires increase. They just go together. And the fire season in the United States West is now 105 days longer than it was in 1970. The fire season is practically all year long now. And California has been on fire literally in recent years. Unfortunate for them, the 3 most expensive wildfires in the world have happened in the last 2 years, all in California. This is a stunning picture I had to include, taken from the Ronald Reagan Presidential Library. This shows the incredibly long fire lines that these firefighters have to fight. How do you put that out? It just marches on. Now, since 1972, the average area burned each year in California has increased by 500%. And they're still going on. It's still an unfolding tragedy as we meet tonight. But it wasn't just California. It was Tucson, Arizona. It was Santa Rosa County, Florida, where thousands of people were evacuated when wildfires became out of control. In central Russia, where Vladimir Putin has no political problems, he declared a state of emergency when 21 million acres burned last year in Russia. Now, a lot of the fires in Russia are very far north and in Siberia. 5 million acres in Siberia burned in May of last year. And notice the fires now propping up north of the Arctic Circle. This is a new phenomenon. And these boreal forests that are in these areas are now carbon sinks. But as we burn them, they're literally going to become carbon emitters. And it already is happening. The June 2020 fires in the Arctic released more CO2 than Norway's entire annual carbon emissions. And some of these fires have become zombie fires. They burn in peat fields underground. They literally last through the winter, then come back, ignite in the spring. Now, this kind of peat fires kind of reminded us of what happened in Moscow about 10 years ago, when 55,000 people died when the peat fields all around Russia caught fire. The people weren't killed from burns, they were killed from smoke inhalation, because the peat releases very toxic chemicals. But as a result, all the farmland was scorched, and Russia had to halt their grain exports, and Ukraine followed with restrictions of their own 4 months later. This led to record food prices spiking 2 times in 3 years. And what I'd like to emphasize in the course of this presentation, that these things have geopolitical consequences, because this event caused food riots in 60 countries. A very famous one occurred in Tunisia in 2011, where a food merchant, set himself on fire in the street. His last words were not "death to the tyrant." His last words were, "How am I to live?" Because he could not afford food enough for his family, let alone to sell in his food cart. This also made me recall the story of Ahmed Abdullah, a Syrian farmer. In 2010, he was telling people that he used to have 600 acres a wheat, but now it's all desert. So he had to take his family, along with so many others, because of the drought that turned 60% of Syria's fertile land into desert and killed over 90% of farm animals. Mr. Abdullah had to join 1.5 million people crowded into Syria's already overcrowded cities What happened next? The Syrian Civil War. Don't think the Defense Department hasn't noticed this. 2014, they put out this missive saying that food and water shortages, refugee problems, battles over resources, natural disasters are literally changing their military mission. How prescient was that? 1 year later, the drought and war in Syria led to a huge influx of refugees coming by any way possible into Europe. And as you recall, they were not welcome. And this photoshopped image of an endless line of apparently Middle Eastern people flowing somewhere was a billboard that probably had more to do with the Brexit vote leading the way of leaving the EU than anything else. We were told by the leaders of the Brexit campaign. Fear works. And the demagoguery has also been present here in this country, where refugees from Central America have been labeled as being in caravans and taking out our border. Well, but they're not coming from Mexico. Where are they coming from? Why are they moving 1,000 miles? It's this dry corridor in Central America that's been created by climate change. And these are heavily drought-affected areas: Nicaragua, Honduras, and El Salvador. This is where the refugees are coming from. It's not surprising, because Honduras and Nicaragua are all ranked in the top 5 of countries at risk from climate change. They literally don't have water to drink or for their crops. And if they get the water, they get it in torrents, like they just get 2 hurricanes in November. That's destroying infrastructure. So it's only going to get worse down there. There's so much climate instability and fear of this changing environment. These people have to do something. They don't have anything to eat. Think about what you would do. So we know climate change is affecting our food supply in many interrelated ways. Due to time constraints, I'll just talk about a couple of these. First, let's talk about heat, the obvious one. Well, it doesn't affect our food supplies because most of our crops were hybridized over hundreds and hundreds of years ago to survive in a climate of that era. Now it's hotter, and these same seedlings are not doing as well. We're underestimating how sensitive our food crops are to increased heat. Scientists have told us that projected yields for these 4 crops, corn, wheat, rice, and soy, will decrease by these percentages for each 1 degree centigrade of additional warming. And these 4 crops make up 2/3 of human caloric intake. This ties into nutrition, because the plants, in order to fight off the high carbon environment, have to use more of their proteins, and these nutrient levels are reduced. So in their harvest, the yields are not only going down, the nutrient value of the crops is diminishing. Climate change is also a medical emergency. According to the Lancet, which has repeated this several times over the last few years. How does it affect our health, our public health? Again, in a myriad of interconnected ways. I'll talk about a couple of them now. Heat stress is a very potent climate effect, mostly on the poor, homeless, the elderly, people that work in agriculture, those that with a lot of pre-existing conditions. They're the most vulnerable, and they suffer the most. But this really is not merely just some third world problem. Extreme heat events cause more deaths annually in the US than all other extreme weather events combined. Allergens, those with hay fever and other airborne allergies are not going to be pleased to know that pollen is set to levels in the atmosphere is set to close to triple in the next 20 years or so. And lastly here, or not lastly, but our killer really is air pollution. Air pollution, as we define it here, is air pollution from combustion of fossil fuels, which is leaves a very particulate type of air pollution. And this is the most insidious. air pollution worldwide is killing millions of people every year. Every country in the world is being affected by these losses, such as India, where in 2016 or in 2017, 13% of all deaths in the entire nation are attributed to air pollution. In Warsaw today, a new infant born will inhale the equivalent of 1,000 cigarettes his first year of life just from the air pollutants in the atmosphere. And here in the United States, where 40% of our residents live in counties that don't meet EPA air quality standards. They're forced to live there because they're close to jobs, but they also have low taxes and low prices, and they have very little political power. These are the people who live in these communities, the people of color, people of limited means. So it shouldn't be surprising that African Americans are 3 times as likely to die from particulate air pollution as the overall population. This, by definition, is an environmental injustice problem of something that we have to take account of as we address this climate crisis. We learned a lot about pollution and pandemics in the last pandemic, the flu pandemic of 1918, 1919, where they found that cities with the highest coal pollution saw 10% higher mortality rates. Well, the Chinese did another study this year of 324 cities and found, again, a marked increase this time in COVID cases in areas which had elevated levels of nitrous oxide and particulate air pollution. So it shouldn't be surprising again that Black Americans are more than twice as likely to die from COVID as white Americans. And infectious diseases also are on the rise because we're disrupting the natural ecosystems. It's making it a way for the vectors that spread the disease, the bugs, the insects, etc. They're now leaving their tropical homes and finding their way on airplanes and ships and whatever, but they're finding hospitable environments up north and south from the tropics, and they're sticking around. West Nile virus does not belong in West Allis, Wisconsin, but that's what's happening now as these disease vectors are on the move. For instance, tick-borne diseases more than doubled in the US from 2004 to 16, and mosquito-borne infections increased nearly 10 times. So this is, we're not immune to this either. As the climate changes and more people are moving further and further into the wilds, they're coming closer to wild animals. 5 new infectious diseases are emerging on average each year. And it's not a coincidence. 75% of these emerging diseases are zoonotic, meaning they are transmitted from animals to humans, like we've been told COVID-19 was from bats. But climate change is also increasing the risk of many waterborne infectious diseases as well. And again, although we don't see a lot of cholera, dysentery here in this country, when we do see it, there's more than 2/3 of these outbreaks are preceded by extreme precipitation events in this country. And the toxicity is not just limited to land, but various species of ocean life are affected as well. The highly toxic red tides that have been inundating Florida are a direct result of the superheated oceans. This killed fish, manatees, sea turtles, maybe even possibly this whale shark. And it's been devastating to the Florida economy. And unfortunately, overfishing, these toxic algae, ocean acidification, ocean temperatures are also decimating marine vertebrate population, which has declined nearly 50% since 1970. We're now at risk of losing 50% of all land-based species this century as they migrate north or they perish, or obviously in some places south. So I've tried to cover many of these costs of this carbonized atmosphere But one that I haven't yet, and we're going to talk more about now, and that is what the World Economic Forum says is the number one threat to the global economy. They said it now 3 years in a row. It's climate change. Besides the widespread property and infrastructure disruption, it's becoming a financial crisis as well. Let's just look at one industry that you don't have much sympathy for, but let's what's happening to it. The vast majority of carbon reserves really that are now under on the balance sheets of oil and gas companies throughout the world are largely now unburnable, because we're, as Al Gore has coined the phrase, a subprime carbon bubble. Remember what happened in the subprime mortgage bubble? Well, he explains it this way. This circle represents all the fossil fuels burned from 1850 to 2010. This in the middle, the amount burned since 2000. This large circle here represents all the remaining proven fossil reserves that are currently on the balance sheets and reflecting the stock prices of major and oil companies, both private and sovereign. This is the amount that's actually burnable if we're going to keep our temperature under increases under 2 degrees centigrade. That means that close to $20 trillion in reserves have to stay on the ground. This is why they fight so hard. There's a lot of money involved, and we're going to have to deal with this problem. But the oil companies are starting to see it. And even the BP's head of strategy says a lot of our unextracted resources will never see the light of day. They can't. But now, what we're finding out now is that maybe finally we've now reached the long-awaited peak fossil fuel demand. And I believe this time they're actually right. What is a peak demand? How does that work? Well, generally incumbent technology such as fossil fuels predicts the future based on current consumption patterns and doesn't take into account the upstart challenging technology, in this case renewables. And what happens is their actual sales plummet as the challenging technology takes them away and leaves them with stranded assets. And this is what's happening in the oil and gas industry. Recently announced, all these oil and gas companies are taking massive write-downs. If you've had these in your stock portfolio, you maybe have noticed it. Since the beginning of the Great Recession, the S&P has nearly tripled. What's happened to these conventional energy stocks? Done nothing. Now, it's not all energy stocks. Since the inauguration of our current president, clean energy companies have gone up 60%, whereas fossil fuel companies have dropped another 12%. So, and this is in spite of the fact that we're subsidizing fossil fuels to a terrific extent. Worldwide, 36 times that of renewables. So even in spite of these subsidies, they're still failing. Here in this country, a lot of people have said the only reason renewables are cost competitive is that we subsidize them. Well, actually, it's the other way around. It's the only reason that oil and gas is competitive. We subsidize them 24 times more than renewables here in this country. So must we change? Yes, we absolutely have to. Can we change? Well, this is where things get interesting. The residents of Easter Island consumed themselves out of their entire island life. They disappeared from the face of the earth. They had no other options. But we have solutions. We don't have to become like them. We have solutions at hand. But first we have to understand which solutions we need to encourage and which we have to discourage. You can see the top 4 here that we need to encourage are renewables, and those that we have to discourage, especially coal, to a lesser extent gas, natural gas. We have to discourage that in order to save this climate. But we're doing it. This is the story I'm so anxious to tell you today, because the wind energy capacity worldwide of installed wind energy turbines is going up exponentially. And even here in the US, the trend is incredible. And as these things happen, economies of scale kick in and the prices start to drop. So it just reinforces the change more and more. Same thing is happening in solar, where worldwide the curve is even steeper. Here in the United States, solar installed photovoltaic capacity is skyrocketing. And as you would expect, the cost per watt of solar generated is plunging from about $80 a watt when Jimmy Carter installed those solar panels on the White House roof to about 20 cents a watt today. Economies of scale and market forces actually are working to benefit this. Right now, they've had a lot of subsidization of energy in Germany. It's paying its dividends now, of renewable energy rather. Renewables are producing now 56% of German electricity, first half of this year. United Kingdom generated 18 times more electricity from renewables than they have from coal. Now, it wasn't too long ago, just a few decades ago, after the beginning of the Cold War, that Britain was worried they wouldn't have enough coal to support their ambitious economic plans. Now they have too much. Things can change, and they are here in the United States too, as coal is being supplanted by renewables. Between 2005 and 2017, all these new coal plants were proposed and defeated either in public forum, by legislatures, or by the vote. These existing plants are retired, and these plants had the retirements announced. Coal is being canceled across the world and across this country. Right now, U.S. coal consumption has dropped to levels it hasn't seen since 1978, 40 years ago. For instance, Northern Indiana Public Service, which gets 65% of its power from coal, is closing all those coal plants. Will be replaced by solar and wind. This is in Indiana too now. They've saved their customers more than $4 billion. I love coming to Kentucky for irony. Here at the Kentucky Coal Mining Museum, they're quietly installing solar panels on the roofs to save the museum at least $8,000 to $10,000 per year. But don't tell anybody. But today, more than 2/3 of the global population lives in countries where solar and wind are the cheapest source of new bulk energy generation. But the key to the long-term success of replacing fossil fuels is developing storage systems. And that is the new growth industry coming forward. Now, if you notice, this chart really is a forward-looking one. But clean energy storage deployments have doubled 2017, 18, and again in 19. The trend is unmistakable. The development of efficient batteries to store energy when the wind isn't blowing and the sun isn't shining is crucial and is moving along rapidly as the decline in battery prices is been noticeable, and allowing things like battery-powered lawnmowers and many more cars. And Tesla to build the world's largest lithium-ion battery and a wind farm in South Australia to retain the energy of the wind farm. Not to be outdone, Florida Power and Light just announced to replace 2 natural gas-fired power plants with solar farms supported by a battery 4 times larger than the one I just described in Australia. The trend is unmistakable. We, friends, are now in our 4th societal revolution, beginning with the agricultural revolution about 8,000 years ago, the industrial revolution about 250 years ago, the digital revolution of the last couple of decades we're now entering the sustainability revolution, the reorganizing our economy around sustainable, healthy growth. And this change is going to hit with the magnitude of the industrial revolution and the speed of the digital revolution. It is the biggest new business opportunity in the history of the world and the greatest way to create new jobs. But we have to take care of the people that are being displaced. And the European Commission has proposed a 44 billion euro fund just to transition workers such as these to new jobs. Here in the United States, it would take a fraction of that, just $2 billion to retrain a majority of our coal miners in jobs in the expanding solar and wind fields. Why not? There are nearly 5 times as many jobs in solar as there are in coal mining right now. It's only going to grow. Over the last 5 years, solar energy jobs have grown 6 times faster than the overall job growth in this country. And now we've won the political argument. And that 70% of US voters now support requiring 100% of their electricity in their state to come from wind and solar by 2050. That's a terrific accomplishment. Bulk energy transmission, or bulk energy electrical generation seems to be well on its way to transformation. But in this country, that leaves us with our transportation system as one of the largest polluters going, and something that we have to address now that we seem to be addressing the generation of electricity issue well. But that's where, again, electricity is coming to the rescue, because plug-in vehicles and hybrids are growing, again, sales exponentially. And what reason why? Fossil fuel cars, construction costs continue to go up, whereas mainstream battery electric cars, assembly costs continue to plummet. And by 2023, they're going to cross. And from that day forward, electrical cars are going to be cheaper to manufacture, and that's when the things are going to really take off. Many European cities have announced bans on internal combustion vehicles already take effect over the next decade. Countries are planning an entire countrywide fossil fuel vehicle phase outs. Many countries across the world have set dates for this. General Motors believes the future is all electric. Right now, there are 11 million people globally who work directly or indirectly in the renewable energy sector, and pretty soon they're going to be joined by people in the automotive sector as they become part of this renewable energy revolution. Solar installer is forecast to be the fastest growing job category in the US for the next several years, followed closely by wind turbine service technicians, a close second. So can we change? Yes. Will we change? Well, we already seem to be. But this now gets into more of the political realm of changing minds. Now, Norway's sovereign wealth fund has now begun divesting from its own oil and gas investments. That was a significant development. Wall Street has now figured this out, that innovation and global markets and economies of scale are now a juggernaut that's decreasing prices of solar and wind components and EVs and LEDs. It cannot be stopped, they say, regardless who occupies the White House. I'm not that quite optimistic. I feel the president can both accelerate and decelerate these changes, but that's Goldman Sachs after all. But what they're seeing, this is what led to that opinion. States across the country are committing to using 100% clean energy by 2050 at the latest. 112 financial institutions have announced they will stop financing coal-fired power plants. Over 250, or nearly 250 global companies have made a commitment to go 100% renewable. These are those companies. But it's not just 240. What Goldman Sachs is noticing is that clean energy purchase agreements are now skyrocketing, because in order for these 240 large companies to make their commitments, their suppliers have to be compliant too. So they're driving the change from hundreds of companies to thousands of companies. Now, speaking of thousands, the people are starting to understand what's going on. 500,000 people flooded the streets of New York during one of the last climate conferences during the last administration. People have figured this out. And in 2015, we were rewarded, where every nation in the world agreed to work together to achieve net zero greenhouse gas emissions by mid-century. A terrific achievement. How do you ever get 184 companies to agree to the same thing? Now, I know there's some bad news here, because the U.S. could not legally withdraw until the day after the 2020 presidential election. And in spite of the loss, he did it anyway. But they're holding the door open for us, and we should not miss a step rejoining it after the first of the year. And for those skeptics out there saying we're getting fleeced, no way. Look at China and India are both on track to overachieve their Paris commitments. So we're not alone. We would not be alone in this fight. But we as a population must resist what? The inertia of the status quo, the unscientific answers of the polluters and those making excuses for them. We have to resist this and join those who are using their voices, their votes, their choices to fight the climate crisis. So please, use your voice, your vote, your choices to take action now. Speak truth to power, like your world depends on it. Because in reality, the world actually does. Thank you for your time. Now, I'd like to direct you to my email address here if you have questions that aren't answered today and wish to contact me for various reasons. I'm offering that email address to you. I'll repeat it in a minute. Also, if you'd like this handy tear sheet here of examples of actions to take and choices to make, you email me and I will send you this wonderful little piece of paper that gives you some things that you can do. Also, I'll give you a link to a debate I had against Steve Gorman, the most prolific climate denying author in the world today. A professionally monitored debate at the Wilmette Public Library in front of 100 people. It's an excellent two-sided conversation. You can maybe determine who won and send me an email and give me an idea who you think did a better job. But please, if you want to ask a question, set up a presentation, solicit printouts, or just make a comment, don't hesitate to do so. All right, now I'm going to give my screen back to my hosts.
Thank you very much, Kent. Thank you.